Hi guys, so the homework answer key was posted on Google Classroom. I figured that they were pretty straightforward, which is why I did not include them in today's video. So if you do have any questions on any of those, of course, please feel free to send me an email. Today we're going to be getting into rotations of 2D objects. So if you spin a dime on a tabletop, the image of a coin rotation looks like a sphere. This is a demonstration of how a circle, when continuously rotated about its diameter, creates a sphere. When we rotate a two-dimensional object around a rotation axis, we can generate a three-dimensional object. The rotation axis is the line around which the objects rotate, just as the Earth rotates around its own axis every day. In the coin example above, the rotation axis is the diameter of the circle. Rotating different shapes will create different figures. So far we have that rotating a circle will create a sphere. Rotating a rectangle around its central axis will create a cylinder. The central axis of a rectangle is the line which intersects, not interests. Intersects the midpoints of opposite sides. The diameter and height of the resulting cylinder would each equal the lengths of the sides of the rectangle. Okay, so see how there is a rectangle kind of inside this cylinder here. So essentially, if you were to take a rectangle, okay, and rotate it around, it would create a cylinder. Okay. And that is, by the way, if you rotate through the center of the rectangle. Okay, so rotating through the center of the rectangle. You can also rotate along one of the edges of a rectangle. So if we rotate a rectangle using a side as the rotation axis, the result is also a cylinder. So now notice that we're rotating along one of the sides of the rectangle. We still get a cylinder, but the difference is when we rotate through the center of a rectangle, what we end up with is the diameter, versus when we rotate along the side of a rectangle, what we end up with is the radius, okay? Rotating an isosceles triangle using the altitude of the triangle that is perpendicular to the base as the rotation axis, the result is a cone. The altitude of the triangle would equal the height of the cone, and the length of the triangle's base would equal the diameter of the cone's base. So if we take this right triangle here, rotate it around, we notice that we get a circle, okay, on the bottom, and then a triangle on the top, which creates a cone, and then the bottom would be the whole diameter of the circle, okay? If we rotate a right triangle around one of its legs, it's also going to create a cone. The height of the cone would equal the length of the leg, which lies on the axis, and the radius of the base of the cone would equal the length of the other leg. So now, kind of just like with the rectangles and the cylinders, now since we're only rotating about one of the legs of the triangle, now what we end up with is the radius of the cone as opposed to the diameter, okay? Okay, so model problem. Describe the object formed when the right triangle to the left is rotated about the y-axis. What is the volume of the object? Okay, so what you kind of have to imagine, and I know that this is difficult to imagine, okay, is that we're taking this triangle and imagine kind of just rotating it around. And I'm going to do the best that I can to kind of draw this out and explain it. But so let's just say, I don't know, it would be like here, here. Okay, so we're rotating this guy around, and as it kind of comes around, okay, what happens is it kind of creates a cylinder with a cone cut out of the middle of it. So because there's nothing in this whole space, what we're kind of actually getting is that we have a cylinder that's getting created. And again, I'm going to draw this to the best of my ability. Okay, and then we get a cone that's kind of been cut out of the middle. Okay, so this is kind of what we're ending up with. And you can see here kind of on both like the right side and the left side here, this is the right triangle that we started with. Okay, so that's kind of what we end up with. So what they're saying now is find the volume of this object. So what we have is a cylinder that has had a cone cut out of it. So what I want to do is find the volume of the cylinder and then subtract the volume of the cone. So we're going to do the volume of the cylinder minus the volume of the cone. Okay, so we would have pi r squared h minus 1/3 pi r squared h. Okay, we know based on the measurements that they're giving us here, okay, we know that the heights are 3, and here we can see that the radius is going to be 4. So when this whole thing gets rotated around, it creates the whole circle or the diameter. So what we have here is that the radius is 4. Okay, so we would have pi times 4 squared times 3 minus 1/3 pi times 4 squared times 3. If we leave this in terms of pi, we would get 48 pi minus 16 pi, which would be 32 pi units squared. Nope, units cubed, sorry. We're finding the volume, okay? And then if you actually calculated that, they don't tell you how to leave your answer. So if you actually did 32 pi, it would be about 100.5 units cubed. So because they do not specify, you could leave your answer either way. Obviously on a test, I will specify, but because they don't specify here, you can kind of do it either way. Okay. Okay, number 1, what type of object is formed when the circle is rotated about the line? We said that whenever we rotate a circle, we are always going to end up with a sphere. Okay. Number 2, what type of object is formed when the square is rotated about the line? So we said whenever we're rotating a square or a rectangle, we are always going to end up with a cylinder, okay? And now notice how this is being rotated. It's being rotated about one of the edges of the rectangle. So we said that when we are rotating about one of the edges of the rectangle or the square, what we're actually going to end up with is the radius of the figure. Okay, so we're going to end up with the radius of the figure. So what happens is, and again, my artistic abilities are not great, but hopefully you'll get the idea. So we're going to end up with some cylinder. Okay, they tell us that each side is 5. So we know that this is 5, and then we know that when we rotate about one of the edges, we end up with the radius being 5 as well. So this is kind of the cylinder that gets created when we rotate this. Okay, so what we want now is the volume of the object formed. So we're going to do the volume of a cylinder, which is pi r squared times the height. So we would have pi times 5 squared times 5. Okay. This would come out to be 125 pi units cubed, or again, if you actually calculated it, it would come out to be 392.7 units cubed. Okay. I want you guys to try 3 on your own, okay? So they say, describe the object form when the figure below is rotated about the line. What is the volume of the object? So notice that you have 2 shapes here, okay? You have a square down at the bottom here, okay? And then you also have a quarter of a circle, okay? So think about what kind of shape are you going to get when you rotate a rectangle, and what kind of shape are you going to get when you rotate a quarter of a circle, okay? And then because it's composite, you want to find the volume of what the bottom shape would be, or shape 1, find the volume of what the top shape would be, or shape 2, and then add them together, okay? So I want you guys to try number 3 on your own. Number 4, the area between 2 concentric semicircles is shaded below. Describe the object formed when the shaded figure is rotated about their extended diameter. Okay, so essentially what is happening is we're taking this figure, we're rotating it around. So we said that whenever we kind of rotate circles or semicircles, we're always going to end up with spheres. So we end up with something like this. Okay. And again, mind you, this is a sphere now. Okay, so I'm gonna kind of do like you see with spheres, those dotted lines to indicate that it's kind of going around. And again, I know that my artistic ability is not the best here. But what happens is we end up with kind of a larger sphere on the outside, and we kind of end up with this spherical cutout, okay? So we kind of have this spherical hole in the middle. And because there's a hole, that means that I want to find the volume of the larger sphere, and then I want to subtract the volume of the smaller sphere. So we're going to do the volume of the big sphere minus the volume of the small sphere. Okay. So we would have 4/3 pi r cubed minus 4/3 pi r cubed. Okay. The big sphere, the radius of the big sphere, okay, is this whole part here, okay? And we know that if this part here is 6 and then the radius of the smaller sphere is 6, well, any point on this smaller sphere is a radius, okay? So the radius of the larger sphere is kind of this whole thing here, which would be 12. Okay, so the radius of the larger sphere is 12. So we would have 4/3 pi times 12 cubed minus 4/3 pi times 6 cubed. The radius of the smaller sphere is 6. Okay, and that one's kind of easy to see. So this is going to give us 2,304 pi minus 288 pi, and if you leave your answer in terms of pi, you are going to get 2,016 pi inches cubed. And if you did not leave your answer in terms of pi, you would get 6,333.5 inches cubed. Okay. And then I also want you guys to try number 5. Again, in number 5, you have 2 different shapes here, okay? Think about what happens if you kind of cut the shapes off right here. What kind of shape do you have on the bottom, and what would you get if you rotated it? What kind of shape do you have on the top, and what kind of shape would you get if you rotated it? Also notice that the center of rotation is through the middle of both figures, so think about whether that means if you're going to end up with the diameter or with the radius when you rotate, okay? If you have any questions, send me an email, and good luck on the homework.